Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and what we're going to be considering here today is a simple Boolean reduction. Okay, so we're going to be considering Boolean algebra. Okay, Boolean algebra. Okay, algebra reductions. Okay, and this is the first reduction that we're going to consider in this particular video. Okay, so let's say for argument's sake that we have a function f is equal to a ANDed with a negated a ORed with a b. Okay, and what we'd like to try to do is we'd like to try to reduce this function down to a minimum state. Okay, so the first thing that we probably should do is we should probably distribute the a across these brackets. Okay, so when we distribute the a using the distribution law, okay, and the distribution law says that we can distribute the a across the brackets, so this becomes a ANDed with a bar or a ANDed with b. Okay, now the question is there any identity that we can use in relation to a ANDed with a bar? Okay, well, let's look at a ANDed with a bar as an identity and let's see what we get. Okay, so let's build a truth table for this particular identity. Okay, so we're going to have a single input, which is an a. Okay, and a can take on one of two possible states. It can either be a 0 or a 1, a low voltage or a high voltage. Okay, so depending on what a is, a bar will have a particular value. Okay, so if a is a low voltage or a 0, a bar, its negation, will be a high voltage. If a is a high voltage, a bar will be a low voltage. Okay, now with these two operands, we have the a operand here for the AND, and we have the a bar operand here, or the negated a. We can actually form the ANDing of these, which is a ANDed with a bar. Okay, so we have to AND these two columns together, term row by row. Okay? And we know the way an AND works. An AND only ever gives us a high voltage out when both of the inputs or both of the operands are simultaneously high voltages. And in this situation, what we can see is that both of the operands are never simultaneously high voltages. In this situation here, okay, in this state here, we have a is a low voltage and a bar is a high voltage. And in this state here, we have a is a high voltage and a bar is a low voltage. So never have we got a situation where both inputs are high voltages. So in this situation, we're going to have a low voltage out, and in this situation, a low voltage. So what we can actually see here is that a ANDed with a bar is equivalent to 0. It doesn't matter what the inputs are to this AND, the output is always a 0. Okay, so this helps us in our reduction here. Okay, so what we end up with is a ANDed with a bar becomes 0, and then that is ORed with a ANDed with b. Okay, so let's have a look at this in a little bit more detail. We have, when we AND the a with the b, we have an output, so we can consider this as a single expression, a single term after we pass in the inputs, and this output from this term here has to be ORed with a 0. So the question is, what is the output when we OR something with a 0? So let's consider that. Okay, so let's consider a ORed with 0 as an example. Okay, so we build a truth table. Okay, the truth table. Well, there's a single input. Okay, well, that's what there's two operands. There's an a and there's a 0. Okay, so when a is 0, the 0 input is always 0. When a is 1, the 0 input is always 0. So let's OR these two things together. A ORed with 0. Okay, and we know that an OR only ever gives us a 0 out when both of the inputs are simultaneously 0. So the only place we have two inputs that are simultaneously 0 is in this situation here. So we get a 0 here. Everywhere else we get a 1. And hopefully what we can see here is that the output of a ORed with 0 is actually dependent on what the a value is. So a ORed with 0 is 0 when a is 0. A ORed with 0 is 1 when a is 1. So effectively what we have is that a ORed with 0 is equivalent to a. And don't forget, we have the commutative law that says that a ORed with b is the same as b ORed with a. And so we have 0 ORed with a is the same as a ORed with 0. So this situation here tells us that anything ordered with 0 is going to be equal to the thing that's not 0. In this situation, we end up with A ANDed with B. Okay, and there's nowhere else we can go here. This is a basic AND game. Okay, so thanks for your time. My name is Jonathan Lambert, and that was our first example of a Boolean reduction.